Okay, ladies and gentlemen, we're back. All right, so we have discussed so far plug-in and dynamic braking in a DC shunt motor and dynamic braking in an induction motor. I think we mentioned also that plug-in can also take place in the induction motor by reversing the connections to any two other windings, the stator windings. All right. The dynamic braking in the induction motor, one that we showed is called DC injection. And the energy that is in the rotational energy that is in the rotating mass of the induction motor is dissipated as heat in the rotor windings in this process. So notice that in the dynamic, both the plug-in that we have looked at already, the energy is dissipated in the resistances of the circuits involved. All right, and something that I should have asked you to do during the break was to calculate the amount of power that would have been expended during the braking process for the same problem that we had done before. I should have asked you to do that. But anyway, maybe you can do that later. All right, so let us look at regenerative braking. And we're going to look at it in the three-phase induction motor. It can also take place in the DC shunt motor, the DC motors generally. And the basic principle of operation is that the motor normally would be operating at a particular speed. Let's call that rated speed. But somehow it is driven past rated speed and now acts above that speed. Now, when the machine is acting above that speed, the torque basically, the shaft torque and also the motor torque reverses. And because you have that reversal in the torque, you also now have a reversal in the power flow. So think of the power flow diagram, for example, of the induction motor. Reversal of the torque causes a reversal of the power flow. So the power now will be flowing from the load side back through the machine and eventually out to the power source, the electric power source. Now, as the torque is reversing, it is actually slowing down the machine. So although the machine is now delivering power to, say, the supply line or to a battery in the case of a DC motor, the machine is also slowing down because of that reversal in the torque. All right, so you have a general overview, and I probably don't need to say anything more because I probably talk out everything that I have written. But let's look at regenerative braking in a induction motor, and this occurs when the speed of the motor exceeds synchronous speed. Now, when this occurs, as we said before, the power reverses and flows from the load to the grid. So the grid would be your transmission lines. So the three-phase line or power supply. So the grid, that's that network of generators and transmission lines that you have your power system that basically comprise your power system. Now the wind generator is a induction machine, and it operates basically off the principle of regenerative braking. So it is designed to be operated at a speed above synchronous speed. SCIG is squirrel cage induction generator. Now, if the speed, if the wind gives it a speed that is lower than synchronous speed, then the turbines would not be allowed to turn, right? Because at that time it would be a motor basically. All right, so this would be a setup for the wind turbines. And you know, we have a number of them in the Manchester area and some in the St. Elizabeth area. Wigton Wind Farm in the Manchester area. All right, now, so the basic circuit diagram is shown. All right, what I need to point out is that when the machine is operated as a generator, it also has to receive power, reactive power, from the supply. All right, so this is showing that reactive power flows into the machine, although real power flows from the machine to the supply line. All right, and the prime mover would be driving the shaft above synchronous speed. All right, now reactive power is required to build the magnetic field inside the machine. So if there's no magnetic field inside the machine, then the machine will not operate. Right. So reactive power is required. Now that can be drawn from the AC line, the AC supply line, or it can be drawn from capacitors that are installed for that purpose, basically. Now you can see examples utilizing this in the Wildy. Let me see if I find the page. Anyway, you can look in the Wildy and you will see it. Search for regenerative braking and you will see it. This kind of setup and how they calculate the amount of reactive power that will be required to get the machine operating. All right, now the regenerative braking is probably best, or one of the ways you can explain it is to look at this diagram. And again, you'll find this diagram in the Sharkawi or in the Wildy. That basically kind of explain what is happening with regenerative braking. So, all right. So on the left, you see a bus going uphill. Friction is operating on the wheels of the bus. So that is represented by F here. The weight of the bus is pulling back the bus down the hill. So that's FL. And the motor is pushing the bus up the hill, right? So that's FM. All right. So, and that is explained here, right? Notice now that the speed at which the bus is moving is omega, right? And this is going uphill, it's a little bit slower than synchronous speed, right? So it will be operating with a slip. Right. Now let's see what happens when the bus starts to go downhill. All right. So I think I explained these already. All right. F1 would represent the load torque. So although it's force here now, we're gonna transfer it to a torque, right? So FL here would represent the load torque. FM would be representing the motor torque, same thing we call the torque develop. And there is a relationship between these two. So if one force is acting in the clockwise direction, then the other force would be acting in the other direction. And you probably would realize this when we did the induction motor test. As soon as we increase the load, the machine starts to slow down, right? Which means then that the load is applying a reverse torque to the motor torque or the developed torque in the machine. And when the two torques balance out again, then the machine will remain at a constant speed. So, but while the load torque is operating, the speed decreases to a new value, right? The new value that it settles at is when the two torques again are balanced. Now, to get the balance, usually we increase the input power into the motor to get a constant speed at a new loading. All right, so so basically the point is that the torque develop and the load torque are usually acting in opposite direction. All right. And we spoke about friction on the wheels. This would be representing friction and windage in the machine. Now let's see what happens when the bus starts to go downhill. Now in the figure to the right, the bus is now going downhill. So the load now, the weight of the bus actually pulls the bus faster downhill now. Right, so I pick up a speed and a momentum that carries it above synchronous speed. All right. Now the motor speed now is the developed torque in the motor is now pulling the motor back, right? So the torque is instead of pushing it up, it is now pulling it back, right? So the motor is experiencing a torque developed that is going in the other direction. But notice that the wheel is still turning in the clockwise direction. So although the torques have reversed, the speed is still going in the same direction. All right. All right, so let us translate that now to this diagram. So the diagram of the bus moving up the hill would be represented by motor operation, right? And when the speed increases, so remember now, this is a torque slip curve, our torque speed. So when the speed so synchronous speed would be at 100%. When the speed increases above synchronous speed now, As we see here, the torque has reversed. So in the motor operation, the torque was positive. In the generator operation, now the torque becomes negative. Right? And basically will follow this curve, which is basically a reflection of, well, yeah, I guess we can call it a reflection or an inversion of the other curve. So when the motor speed increases above synchronous speed, the torque reverses. The motor torque develop reverses. And it becomes negative on the torque speed characteristic. All right. So when the torque becomes negative while the speed is in the same direction, then the power becomes negative. Anybody remember the relationship between power and torque? Anybody? You can open your mic and tell me.
The output power is equal to the torque times the um, omega s, which represents the shaft angular speed.
Okay. All right. Omega S is actually what we call synchronous speed. So what we have been used to omega M, right? Right. So the power is equal to the shaft torque TS omega M. Right. Now since the torque has reversed, has gone negative relative to what it was before, then the power becomes negative. Right. So if the power becomes negative, it means that the power is going to flow in the other direction. So the power is now flowing from the load to the source. Right. But because the torque has reversed, it is actually slowing down the machine also. So braking is taking place. So that is the regenerative braking. So as braking is taking place, it is generating power too, that can be utilized in the utility, the three-phase supply line that initially was feeding the motor. All right. So you will find this in the different books, the torque speed characteristics of the induction motor. I have, sorry, I had asked you also to look in the Sharkawi at 4-quadrant operation. So that is, you will actually see 2 quadrants here, maybe 3. And I want you to study them. I think it's page 107 in the Sharkawi. Right. So because this is now an aspect of drives that I want you to read up on. Right. So read up on the 4-quadrant operation, and also for drives, I want you to read up on chapter 1. I think I'd indicated the pages that you should read, the places that you should focus on. But the chapters are very short in the Sharkawi, so it's like a half an hour read. But you should understand the different component blocks of the drive system and should be able to describe them. I wonder if I have the book open. All right, so in
Sorry, sir.
yes,
You said the 4-quadrant.
right. 4-quadrant operation of electric drive. Let me see if I find the book. I had sent an email with that last week,
Oh, okay.
All right, right. So that part is on page 108, 4-quadrant electric drive system. So that is important because it will help with understanding of this also. And then I had also asked that you look at chapter 1 and all right, let me close this. So this is the book that I sent you. And if you, let me see if I have it open. Yeah. Page 5. All right. So I had gotten this diagram from it. And then the 4-quadrant operation. So this is what I'm talking about. Yeah. Didn't need to go back to the book to the physical copy of the book. All right. So yeah, you need to understand these. And it's not one of those books that you touch a number and the page comes up. Right. So I wanted you to understand chapter 1, since we're actually doing electric drives. Right. So different type of drive systems. Right. And then the basic components of an electric drive system. So you have a power source, you have some means of yes.
Are you sharing your screen?
Oh, sorry. Oh, my apologies. I thought I was doing that. Where are we? All right. So this is. All right. Let me go back. So this is the book that I sent you recently, Sharkawi. All right. Fundamentals of electric drives. And I'd ask you to focus on 2 sections. But I want to point out that chapter 8 and chapter 9 and chapter 10 will give you some information on braking also. Right. All right. So you need to understand the elements of a drive system, electric drive system. And there's a block diagram here that will give you that overview of what a drive system would look like. So you have a power source, you have some means of converting that power, voltage, frequency, etc., to something that the machine, the motor can handle, and the motor will be supplying some kind of mechanical load. All right, and then you have a controller that basically takes information from the load, from all of the different parts to make adjustments so that the right parameters are sent back to the motor to give you the adjustment that is needed. All right, so you really need now to understand the different type of power sources. Yeah, this was something about different type of mechanical loads. All right. All right, so information is here about different types of power sources, generally AC and DC, right? Then converters and the different type of converters, DC to AC, DC to DC, AC to DC, AC to AC. All right. And they show you how the conversion, what happens during the conversion. All right. And then they speak about the controller. All right.
Excuse me, sir.
Yeah.
Sir?
Yes, go ahead.
So all this, yes, just confirming. So all of this week.
All right, you're fade out. You say all of this week?
No, I was saying all of this information is critical for our exam next week.
I will. It's let me answer this way. It's critical for your knowledge, right? But this is like a half an hour read. Once you draw the block diagram, you should this block diagram. You should be able to explain exactly what is happening. So usually,
Okay.
it is like I might ask you about one component of this block diagram. Usually that has been the case. I ask you about one component of the block diagram, and then you could explain it usually. But you should know how the diagram set up. Yeah, but it's not very difficult read. And you'll be familiar with most of these already. So yeah, so that was something that I had given you to read from last week. So if you haven't done so yet, just a quick read over and read up on the 4-quadrant system, right? Because I have actually asked questions on the 4-quadrant system already too. So I wouldn't want to shortchange you compared to what others have gotten before. There's actually an induction motor regenerative braking type of question. But as I say, I don't have it with me here at home. I would have to go back to work and find it. So if you get it, then you get a hint. If you don't, then you have to work. All right, but yeah, in terms of the exam, we basically have covered everything that we need to cover. So if you read up on what I've told you to read up on, so check that last email that I had sent with reading assignments. If you read up on those and you do what I have asked you to do throughout the semester, if you look at what we have covered throughout the semester, then you should be in good standing. I don't expect anybody to fail. I expect
So what about the topics that I say we have pay keen attention to now?
Oh, I thought I just did. Didn't I? Like everything that we have covered in class from.
You know, sir.
Huh?
There's a whole,
So
a
sorry,
whole lot.
sorry, I was saying definition question.
Definition. What's a definition question? Like what is braking?
Like explain the principle of operation of like a three-phase motor. Like questions like that.
Oh, so that would be a description, right?
Yes,
more than definition, right? So yeah, description maybe there.
I mean, I work with no maybe.
Well, if you cover all the I know you guys have all the past papers. So if you and if you don't, Mr. Grant say him have everything. I wonder if Mr. Grant is here. No, I don't see I don't see Mr. Grant today. But he told me that he has everything, so he's I guess a good source. Yeah, all right. So unit 1, induction motors. That will be there as of course. Unit 2, synchronous generators. Unit 3, the synchronous motor. All right, let me stop share for a little while. All right, so I'm gonna bring up the exam now. Everybody okay with that?
Yes, sir.
Yes, sir. Most definitely.
All right.
Sir.
So, Miss Michael, aren't you going to object?
Sir?
Aren't you going to object? They want me to show them the exam.
Sir, I thought you mean when you said bring up the exam, you mean like just talk about the topics.
Oh, okay. All right, good. All right, so you understand? Everybody understand what? Say that again?
We know you're not going to do that.
Oh. All right. Can you see my screen?
No, sir. You haven't started sharing as yet.
Oh. All right. It's coming up. All right, so it's a 2-hour exam. And it's supposed to be on the 9th of December at 5 p.m. So you will have actually 3 hours in which to submit. So that is more than you really need. Right. So there will be, yes, induction motor, synchronous generator, single phase motor, synchronous motor, braking, transformers. Right, so that is it. All right. Everybody seen my screen?
No, sir.
No, sir. No, sir.
Oh, look like technical difficulties. Oh, wow. I'm sorry. I'll have to work on that.
Sir, what I wanted to ask also is about the lab. If we could get an extension to submit.
How much extension you want?
Maybe up until Friday.
Until Friday? Okay. Okay. Yeah, no, that's all right.
Okay, sir. Thank you.
What I wanted to do was to make sure that I was able to mark it and give you your results that you're going into the exam with before the exam day. But if you're okay with not getting in your final marks going into the exam, that's okay.
So I think it'll be fine if you get everything except the lab, so we just have an idea, you know.
Okay. All right.
Yeah.
No problem.
Everything except the lab will work also.
Yeah. All right. I think I probably could send that today then.
Yeah. So we'll
Okay.
have an idea of what's going on.
Yeah. All right. Let me see if I can bring that up now too. No, but I don't want to show. I don't want everybody to know what everybody else is doing.
That's it. So you can go ahead and share your screen, say, you know.
Let's see if we sort out that technical difficulty. All right, yeah. All right. Yeah, we have some marks here. Yeah, just a couple people are about 3 persons I'm a little bit concerned about. So they would have to turn around things significantly. So if you're below 20 out of, because this would be out of 40. So if you're below 20, you would be a little bit in trouble. Let me. All right, let me see if I. So you want me to share the screen with that, or just send it to you directly?
No, so you can just send it direct.
Okay. All right. Yeah, but for most persons, I'm not concerned. I think people should do well. But if you when you see your results, if you're below 20, then you know that you have a lot of work to do. And there are about 3 persons below 20. All right.
So the class size is like 10 of us, you know, that's like 1/3 of the class.
11, right? 11 of you. So right, about 1/3 of the class. So 3 out of the 11. Maybe a little bit less than 1/3.
Yeah.
Right. Yeah, so 3 of you need to step up a little bit for the finals. But I have no doubt that everybody will pass still.
All right, so let's just make sure the exam is in accordance with that. The difficulty level can allow for that.
Yeah. And you're actually getting, well, you have 3 hours to return it. If you don't return it within the by the 3rd hour, then I guess you would get 0. So try to work.
So we have 2 hours to write the exam and an extra hour to submit it.